Hey guys, today we are going to talk about two different theorems of the factor and remainder theorem. And really what these two things are going to help us do is help us factor things out and also help us prove that certain traits of the graph are true. So your essential question is, how do I use the factor and remainder theorem to simplify polynomials? So we're going to go ahead and we're going to start with the remainder theorem. And this is what the remainder theorem says. It says if p of x, that's a polynomial, is divided by the factor x minus c, then the remainder is equal to p of c. So really what that's saying is if you are going to divide a polynomial by this first degree binomial term x minus c, then it's the same value as when you evaluate the function at that point. So this is really useful if you have something that has a really high power in it where you don't want to take 5 to the 5th power because you can't have a calculator or whatever. So basically, again, if you divide this thing into this polynomial, your remainder is going to be what it is to evaluate at that point. So let's do an example of that guy. We have that the function p of x equals 2x cubed minus 7x squared plus 5. So what we're going to show here is that my two things, like for instance, maybe I'm going to evaluate at x equals 3. So if I was to plug that number in, that one's not too bad. I would have p of 3, and wherever I have an x, I'm going to replace it with a 3. And then I just simplify this down, using some algebra or whatever, using PEMDAS. And if I plug that in and I simplified it out, I would get that that answer is -4. Now again, that's going to take a little bit of effort because you're going to have to cube 3 and then times it by 2 and square 2 and blah, 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 blah. If you use synthetic division using that factor, you're going to get the same thing as your remainder. So this is the other way you could have done it. Since we're using x equals 3, we're going to put 3 in our box, and then we're going to write our synthetic division out. So again, we have my coefficients that go down, -7, there is no x term, so there's 0, and then 5. Pull down your 2, and then multiply. So that's 6, -1, -3, add it up, and then we get -9. And so adding those two together, we find out that my remainder and that point where I evaluated are the same thing. So that's just kind of proving that it's the same. And so if they ask you to evaluate a really ridiculous number, you can always just do the synthetic division. Or if they're asking you what's the remainder of this really ridiculous polynomial, if I divide it by this, you can always just plug in that point. Okay? So that is the remainder theorem. Now we're going to talk about the factor theorem. And the factor theorem is something that you've been using. It's just really useful to kind of know how you can go back and forth between your points. So the factor theorem says C is a 0 of p, so of a polynomial, if and only if, so that's, you might abbreviate that as IFF, if, but if and only if x minus c is a factor of p of x. Let's go ahead and write that down. This is a biconditional statement, and so what it's saying here is that if, for instance, I had a 0 that was -2, I would know that one of the factors would be x plus 2, right? Because you flip that sign. Okay, or going backwards from that, if I knew one of my factors was x minus 3, I was used to setting that equal to 0 solving and finding out that the 0 of the function was 3. And so this goes both ways. It's super useful if, for instance, they give you a factor and you want to find a 0, or if they tell you a 0 and you're looking to factor the polynomial. So again, this works both ways, and we're going to use that in order to factor polynomials a lot of the time. So let's look at an example here. We have that this is my polynomial, x cubed minus 7x plus 6, and our goal is to show that 1 is a 0, and then we need to factor it completely. And so when I look here, I'm going to go ahead, if 1 is a 0, then I should get a remainder of 0. It's going to divide evenly into my polynomial. So I'm going to go ahead, do my synthetic division using 1 as my 0. My coefficients are 1. There is no squared term, so I write a 0, -7 and 6. And I just do that synthetic division. And luckily enough, I get my remainder of 0. All that's saying is that x minus 1 with that function would divide evenly into my polynomial, and that's using my zero or my factor theorem. So I know then that one of my factors has to be this, using this theorem, x minus 1. Okay, remember you kind of flip-flop the sign. And then I also know what my other factor is using the synthetic division, because if I think about this guy, I'd have x squared, I'd take my degree down 1, plus x minus 6, so that would be the rest of my polynomial at this point. And then this is just a trinomial, that's what we factored in the past. That's not a big deal at all. You think of the factors of -6 that add up to be 1, and I would have gotten x minus 2 and x plus 3. Okay, so pretty straightforward tonight. We will practice some more of this in class tomorrow, and have a great night.